Okay, so we got this HR21 second generation, and this is electric only machine, no hydraulics, electric drive. So let's see what's happening with it. It was some fault report of the screen going black. Shows no error codes at the base controls. Let's try to operate from the cage to see if that's gonna make any difference. Oh, it's gonna trigger the fault. At the moment it seems to be working fine. I don't see any faults. Okay, so every function is working as it should. Let's see the cage rotate. That's working fine. No problems with that. Alright, so cage rotate is working fine. Let's do a slow drive. I will drive forward just a little bit. That seems good. Steer right, steer left. Drive reverse. Alright, so not too sure what the fault is. At the moment everything is working fine. Alright, let's see if I can record this. So basically what I had a motor controller switching off. That gone red, started to flash red. That gone red, and the machine has restarted. So it did restart it. It was clicking for a while, so I'm not sure what's happened. So I'll switch the camera on now just to see if I can catch this up. Really strange. When that restarted, it sounded like it's a power cut, because the screen gone black, the PLC gone black as well, and the motor controller shut down. So it really looked like it's lost the power supply in the machine. If that would be the canvas error, so I would expect the machine to go into CAN fault mode and stay there. Maybe it's a problem. Oh, there we go. Oh, look what they did. Hey, just touched the step down unit. Doesn't try again. Oh, look at that. This is a problem with the step down unit. What I will do, I'm gonna push it in the middle. Okay, with the finger right here. Look. 1, 2, 3. Oh, nothing now. Yeah, it did restart it. Alright, so I think the problem is with this unit. That's a voltage converter. Okay. So I think the problem is with that. It's randomly dropping out and causing the machine to restart. But what I found interesting, on this machine we should have a combined power supply to the control circuit. That should come from the voltage converter and emergency batteries for emergency descent. Okay, and that should join through this diode bridge rectifier in there. And the one here with the 2 wires. Okay, so this is diode bridge rectifier. If I look on a schematic, let me see if I can get this. So on a schematic you have this diode bridge rectifier, and you have 12 volts. That's the converter. So we have output 12 VCS, and that output goes and connects into bridge rectifier, and then feeds the control circuit. Okay, but what we have on opposite side of the bridge rectifier here 12 VS. That's the power supply from the emergency batteries. Okay, and if I disconnect this wire, no, not this wire, sorry, if I disconnect the converter here, I still should be getting the power into 12 VCS over this diode here. Okay, so I think I will mark it up on a schematic later on how the current should flow into 12 VCS. But I think what happens is, if I disconnect my converter, I lose the voltage on the control side. Okay, and this is what I'm measuring. I have a 12 VCS. So if you look on the schematic, 12 VCS, that's what I'm measuring. Okay, so I'm measuring 12 VCS, and if I disconnect the plug, from the voltage converter, I still would expect the circuit to stay alive because of this 12 volt feed over the diode. Okay, so let's try. Alright, this is the gray plug, so I will disconnect the plug. Look, I disconnect the plug now, this gray plug, from the voltage converter. So I disconnect and the machine died out, so no power. Everything is dead and we have no voltage now. So I'm wondering why we have no voltage here when we should be feeding the control circuit over this diode. Okay, so what I'm gonna do now, I'm gonna measure the voltage on diode bridge rectifier, or maybe actually I can measure the voltage on this, the fuse here, F1 2 amp fuse. Okay, so let's open fuse box and F1. So this fuse here in the top left corner, I should have 12 volts on it. So let's try. Alright, I'm getting only 2.3 volts. So that's where the problem is. I have no power from auxiliary batteries. Alright, so I know if I disconnect step down unit, I lose the power to supply to machine. Okay, so what I done here, I just slew the machine sideways. So this is the front of the machine, steer wheels, and that's where the emergency batteries are located. Try to put some more light in it here. Okay, so if I measure the voltage now on this fuse, this is main 12 volt fuse for auxiliary power, and that's where auxiliary pump is located. So we do have a 12 volt. Yeah, batteries are charged, but we don't get the voltage up to this point here, up to that bridge rectifier to feed the control circuit. Okay, so what I will try to do now, I will try to go over schematic quickly, just to see where the power is coming from and if you can locate the fault that way. So I will try to use my mouse just to show you what it is. But so I have this 12 volt here. Okay, this is the supply, and this is supply that comes from this auxiliary batteries. Okay, so it's coming from auxiliary batteries, and when we lose the voltage on this 12 VCS, which is a voltage converter output. So you see the voltage converter here, and you have a 12 VCS as an output. Okay, and it's going to feed in control circuit. Okay, so this is the main feed to control circuit, 12 VCS. Okay, so when we disconnect this voltage converter, we still should maintain the power on this part through this diode here. Okay, because we have 12 volts coming in here, over diode comes out 12 VCS, and the machine should remain on. So now we measure the voltage on the fuse 1 right here. This is fuse 1 into MB1 fuse box. So we measure the voltage and we have nothing there. So now we need to look where that is coming from. So it's coming from 12 VS. Okay, so connector 12 VS, and that's on a page number 8. So this is where the power coming into this bridge rectifier. So let's go to page number 8. Six, 7. So page number 8. All right. So page number 8, connector 12 VS, and this is our 12 VS wire. Okay. So it goes over isolator. Okay, and goes back to the page 2 where we've been before as AXPBS. Okay, so what that means the power has to come this way. So it comes from connector AXPBS. Okay, so it goes this way, then travels all the way up to isolator. Okay, and through the isolator it goes up to that bridge rectifier. Okay, so let's have a look. Page 2 on connector AXPBS. Let's go back to page 2. That's where I started. Okay, so this is where we started, page 2, and just above that, this is connector AXPBS. Okay, and this is the wire. So now you see that wire, it starts from the connector AXBS, and that's page 9. So let's go down page 9 again. And we are on page 9. Yeah, and that's the connector AXBS. Okay, so that's going into page 2, PLC loom. Okay, and this is the wire that is feeding AXPBS. Okay, so if you follow this wire, if you follow this wire, let me zoom out a bit. Okay, so right, so this is the plug AXBS, this is the wire we feeding isolator, and then we're going to bridge rectifier. Okay, so if you follow this wire, it goes right up to here, the same wire AXPBS. Okay, and this connector AX, and if you look here, you have inline fuse F5 15 amp fuse. Okay, and that 15 amp fuse is connected onto 150 amp fuse, the main fuse. So this is where I measure the voltage on the 12 volt batteries, the main fuse. Okay, that's where the positive is. So this is 2 batteries, that's a positive, and inline fuse 15 amp. So let's have a look on that fuse here. Okay, so this is the main fuse for positive. Okay, so this is my positive here, goes in that fuse, and on that side we have this wire. Okay, so now that wire has this fuse, and that's a plug AXPBS. You see, hopefully you can see identification on the wire, but this is the wire we need to look at, AXPB. Okay, so that's very easy to follow. Alright, so let's measure the voltage now. So let me see if so I'm measuring voltage on this side of the fuse. So I have 12.2, Okay, so now I'm gonna measure on that fuse. Okay, 12.22, and if I measure on the output of that fuse, I have a 13.6 volts. Okay, so the question is the fuse good or bad? Yeah. So that fuse has gone. So what I will do now, I will isolate the machine, because you can see there is a voltage difference on both ends of the fuse. So I will isolate the machine, and then I will try to refit that fuse. And what I will do, I will turn the machine on. Okay, so machine is on. And what I will do now, I will disconnect the step down unit as we did before, and machine gone down as well. Okay, so I disconnect this unit here, and the machine switched off. So now I'm wondering why is that happening? So could that be that we don't get voltage on bridge rectifier again? What I will do now, I will measure the voltage on bridge rectifier. Okay, just to see if we're getting the voltage into it. So that's my voltmeter here. Or maybe I can get this maybe here. So 0 volts, and the other one 12.2 volts. Alright, so we do have the voltage up to bridge rectifier, but we have no power to control circuit. Okay, let's have a look again. So we have 12 volts coming here. Yeah, so we have 12.2 volts, but we have nothing going down here. So I have a feeling that these two wires are mixed up. Yeah, so they are mixed up. If I disconnect this wire and move the one with the voltage across, okay, so I moved, yeah, hopefully you're gonna be able to see them, but I moved the wire from there into next port. Okay, and I'm gonna measure the voltage now on this wire. So I do have 12.2. Okay, so I do have 12.23, and this is the voltage of the 12 volt batteries. And though if I'm measuring on the output on the diode bridge rectifier, I'm measuring 12 volts. So this loose wire here is the wire that feeds the control circuit. Okay, so if I connect the wire on the bridge rectifier, I think the machine is gonna turn on. So let me go to 0. Okay, so both wires connected now. I should have the voltage output on both of them. So 1, 12.23, the next one, okay, 12. So we do have a diode, the voltage drop across the diode, so that is fine. So that's fine. So what I will do now, let me connect my voltage converter back up, turn the machine on. Okay, so machine is on now. So what I will do now, I will disconnect this voltage converter. Right, this cable right here. Okay. There we go. So that's good. So I disconnect this converter. Okay. So that's the plug, and the machine is still on. Okay. So the way it is working now. So now we're getting the power, as we should, from this 12-volt batteries over the diode and into control circuit, exactly as per schematic. So I think what I will do now, I will replace this the voltage converter here, this one here, and I will test the machine, and I think that's going to be end of the troubles here, because so the main problem was the fuse gone, supply, and the diode bridge rectifier was mixed wires on it, so I don't know what happened here, why they mixed up, but anyway, they were mixed up, and voltage converter has failed. That's why the machine was switching off on zone.